Started. Hi, everyone. Welcome to an invitation to learning engineering. Very excited to see so many new and um, old, I don't mean to say old, but and new and folks that have been part of ICICLE for a long time, but also new faces who are interested in learning more about learning engineering. So let's get started. Let's see here. There we go. So we have a full agenda today, so want to get started promptly here. Um, the agenda is introductions, then we'll talk a little bit about the tools and instrumentation special interest group of ICICLE. We're going to show off a case study with Ruiwei. We'll have a Q&A session, and then we'll talk a little bit more about how to get involved with ICICLE. We're going to start with introductions. I'm Erin Czerwinski. I manage a team of learning engineers at Carnegie Mellon University's Open Learning Initiative and the Simon Initiative. I'll let Baptiste and Ruiwei introduce themselves, and then we'll have a poll.
Yeah, hi everyone. I'm co-chairing this special interest group. My name is Baptiste Moreau-Pernet, and I'm a machine learning engineer in a nonprofit education company.
And hi everyone, I'm Ruiwei. I'm a second year PhD student, almost finished my second year. PhD student at CMU Human Computer Interaction Institute, and my research is primarily in the AI in education, AI literacy space. And today we are gonna mainly talk about one of the projects that can demonstrate how learning engineering help a lot in our daily practice.
Thank you. So now for a short poll. So we want to know how familiar each of you are with learning engineering. So we'll give you a few seconds to answer the poll.
Think anybody who's going to respond has responded.
Great, great. Thank you. And thank you all for responding to that poll. So, looks like we have almost an even split. More people are familiar, and we have about 21% new. That's exciting. So you'll learn some things today. Okay. So, what is learning engineering? So, the ICICLE definition of learning engineering is that it is a process and practice that applies the learning sciences using human-centered engineering design methodology and data-informed decision-making to support learners and their development. What this means is that it's really a repeatable, evidence-based process where data is used iteratively towards solving a particular problem in learning design and delivery. And so ICICLE is a volunteer organization that's committed to the development of learning engineering as a profession, practice, and a process. It's been around since 2017, and ICICLE members are found across sectors and disciplines, academia, government, military, corporate, K-12, and higher education. So anyone involved in learning um, design, learning solutions is welcome and encouraged to join us. We have a whole community meeting that happens every month on the third Wednesday, and we're organized into special interest groups and market interest groups. And those groups meet on a regular basis as well. And it's really where the work of ICICLE takes place. We have groups that look at learning engineering from many perspectives, from how to design using learning engineering, what tools are used, what skills are needed in the profession, and how to apply learning engineering in all different contexts, whether it be K-12, higher education, corporate, or military. And we'll show you how to get more involved towards the end of the session, so stay tuned for that. So one thing we all agree on and try to evangelize as much as possible is that learning engineering is a process. This is a process diagram developed by our colleagues, Erin Kessler and Jim Goodell. It shows that in any LE project, any learning engineering project, it starts with a learning challenge or a problem. That then moves into understanding more of that context, and in most cases, the learners that are involved in the solution. Then the solution is determined and implemented with an attention to data collection and analysis. We instrument the experience as much as possible so we can collect data that will help us know more about if the solution is right, or how it can be modified or iterated on further. And so we iterate on the solution, which could be a modification, redesign, additional context, and then documenting this all along the way so that we can begin that cycle all over again. And that's that iterative part. So
yeah, so I'll take over to introduce a bit more, I guess, our special interest group, so the tools and instrumentation, SIG. So it's mainly a practitioner-led community. So we have conversations on how tools enable and constrain the practice of learning engineering. We run monthly working sessions. We examine tools across the full learning engineering process. So as we just mentioned, including the design, data instrumentation, data collection, analytics, the iterative full process of that. And we use these tool demonstrations. We have people come in and showcase their tools. We show case examples and also look at standards to support the learning engineering process. And we ask questions around, what decisions does this tool support? What learning data does it make visible or obscure? How does it shape the design trade-offs, the ethical considerations and the feedback loops, etc. And so over time, the student or the special interest group has served as a kind of sense-making space where the members build this collective understanding around learning and emerging technologies, such as learning and analytics platform, AI tools right now, data standards as well, and as well as developing more practical guidance that helps the broader ICICLE community to make more evidence-driven tool choices. And in the next slide, you can actually have a kind of a glimpse on the few tools that we've been looking at, although not all of them are here. And those tools are collected throughout all the tool presentations that we host every monthly meetings. And the list is accessible actually in our compiled repository here to the left. And to the right, you have about 20 different tool demonstrations and discussion recordings that we've had. So if you want to look at that, you can scan the QR code. I mean, a few examples of those that we're mostly interested in actually because they are open source and developed with the learning engineering process in mind are Upgrade, as you see at the bottom. So this is an open source platform for A/B testing in the classroom to measure the efficacy of different tools and resources by measuring learning experiences. There's also Learning Locker to the bottom right, is an open source learning record store for tracking learning data in any context that's using the Experience API or XAPI structure, which is a standard for managing learning data. And at the top right, you can see the Western Governor University Skills Library. It's an open resource of structured skills data to promote skill-driven education or hiring system. So that's just a glimpse of the diversity of tools that we've had here. And during our conversations about learning engineering tools, we usually analyze them across different kind of characteristics so that the practitioners can choose them appropriately in their context. So for example, licensing, is it free, open source, freemium, paid? The scope, is it broad or domain specific? And the user role, like does it target more analysts, designers, teachers, learners, researchers, etc. In the next slide, I'll briefly introduce our speaker of today for the case study. And this speaker is Ruiwei. She already gave a presentation of herself, and she will talk about this pedagogical agent builder tool that she's building. Yeah, I think very excited to have you present today, Ruiwei, so you can take it away.
Okay. Yeah, so can everyone see my screen now? Wait, what is?
Yes.
Okay. And
Yep, we can see your screen.
okay. Yeah, I just introduced myself, and so I'm just gonna say a little bit more about this case study. So we, in this case study, we have a very, very real and specific challenge. So there is a course called AI for Learning. It's an online course on open learning initiative. So the audience of this course is the instructors in higher education. And since AI in education is so popular and useful nowadays, lots of instructors just very curious about how to use AI in their teaching practice. So for that purpose, Open Learning Initiative just launched the AI for Learning class, and then instructors can just register and learn a lot about knowledge about AI and lots of tools, AI tools they can use in their practices. And one of the learning activity in this online course is using Playlab to author AI chatbots. So I can show you a snapshot of the Playlab platform. So on the right side, instructors can write down the system prompt, like the specific requirement the AI should follow. And on the left side, they can test this chatbot. And at the end, if they are satisfied with the AI's performance, then they can just publish this bot and share that to their students. So typically, instructors will build something that some QA bots, their students can ask questions about syllabus or do some practice questions with this AI. And one day, our team just received a request from one of the OLI learning engineer, and she said, we actually want an upgraded version of Playlab, like a replacement of it. And can anyone just guess about what was the challenge behind this kind of replacement request? Yeah, you can just shout out the answer or just type it in the chat. So anyone has any guesses? Okay. I think this is actually surprisingly. Yeah, go ahead. Go ahead.
Orchestrating the tools outside of the single chatbot and kind of figuring out how do you create a harness?
Create harness of like do you mean like learn some skills that's more generalizable for using AI?
I was thinking more along the lines of creating multiple layers for new users to become accustomed with AI. So they're using MCPs or plugins or different skills in order to do it. Rather, Playlab is fairly linear, and you decide on the background and put instructional layer, and then you're just chatting with that with some reference.
Okay. Yeah, that totally makes sense. And I honestly, this is a little bit beyond my imagination, but this is an excellent answer that we definitely gonna think more about it. Thank you for sharing this idea. Yeah, and I saw a lot of answers from the chat. So the time and expense is definitely the main reason, and that was exactly what I was told. Like Playlab has a plan to charge for membership. So it from the OLI side is quite hard to manage like those personal accounts for their for our learners. So we really want some in-house application. So if it's really need to be charged, at least we can manage the payment for an hour and prevent the loss of learners for our courses. So that's the reason I had when OLI staff reach out to me and want to build a new tool. And the second challenge they proposed to me is that strangely, teachers have very good comments about Playlab and the course, but almost no one ever reopen the bot or even send it to their students, because we can track like in this Playlab shared space, we can track the usage of each bot, but we never seen that number increase after the course. So we really want to figure out where goes wrong, and we also want to provide a better experience to our learners, in this case, the instructors. So we this is just a recap of the learning engineering framework. So we just talk a little bit about the challenges we had in this case. And here we got, we will just watch a demo video of our latest version of the so-called upgraded Playlab.
Welcome to the demo of Prompt Decipher, an AI tutoring chatbot authoring tool that supports a reversed approach to prompting. While existing AI chatbot authoring platforms require teachers to write lengthy system prompts, Prompt Decipher takes a different approach. We generate simulated student AI conversations and let teachers author by simply editing those conversations. Let me walk you through the full workflow. Our system supports Google Login. On the homepage, you can switch between light and dark mode and access all previous bots, both your own and those shared by the community. Now let's create a new AI tutor together. You can select an AI model, paste your API key, and fill in the details. We'll call this one Linear Equation Tutor, with the description, an AI tutor teaching 7th graders linear equations. Let's click Create App. Now we're on the authoring page. On the left, you'll see the system prompt that guides the bot's behavior. It defaults to the bot description you just entered. On the right, there are 2 simulated student AI conversations, one representing a typical interaction and the other an edge case. Here's where the magic happens. Teachers can modify the bot's behavior by directly editing these chat histories. Behind the scenes, our prompt editor agents automatically update the system prompt to reflect those edits. For example, say a teacher wants the linear equation tutor to guide students toward the next step using multiple choice questions. Instead of writing a lengthy system prompt that requires tacit knowledge about learning sciences, the teacher can simply edit the AI's response in the simulated conversation and add an MCQ skeleton directly. Once the teacher submits the changes, the system prompt updates automatically. The teacher can then review the updated prompt, click Apply Current Prompt to regenerate the test cases, and repeat this process until satisfied. Teachers can also add new test cases by configuring a new simulated student profile or start a blank chat from scratch to interact with the AI themselves. When a test case looks good, the teacher can label it as pass. Only when all test cases are marked as passed can the teacher publish the bot and share it with their students.
Yeah, so that's pretty much the latest MVP we built after the entire process of the learning engineering and the discovery. It's definitely not the end of this iterations, because learning engineering is just a super iterative process. But this is based on the discovery so far. So to demonstrate how we initiate this process, after the end of the AI for Educators online course, we collected all the data and analyzed the data. So yeah, which pretty much is we started from the step 5 labeled here, but I don't think there is an order among the steps, or we should start from any of these steps. We can start from any part of it and just make it very iterative. So here in this case, we just start from the data analysis, because that's the all of the things we had back to that stage. So we had all the builds, all the bot metadata from 121 teachers. And then we also have their conversation data with those bots they built. And we conducted quantitative and qualitative analysis. So from quantitative analysis, we can know the number of conversation rounds they had for their bots. We also have a sense of average time spent when they are build and interact with those bots. We can also estimate the dropout, which in this case means the discontinued conversation. And we also do a bunch of qualitative analysis, mainly the thematic coding of the prompt content, the conversation content, and some of their feedback. And we also do the qualitative things with the interaction logs and teachers' justification of their user experience in their feedback form. And after the analysis, here are some takeaways from the data labeling and some discussion in the team. So we found when it comes to the prompting, like in the system, it means like the system prompt teachers wrote to ask AI behave in certain ways. We found teachers are very good at providing the context to the AI chatbots. So for those 121 bots, all of them have a pretty decent amount of context or specific task requirements that teachers wanted to do. However, we found like less than half of the bots are required with some learning design strategies, like whether it needs to scaffold students in certain way, or it should ask students Socratic questions, or any other learning strategies that teacher usually perform when they are interacting with students. And so in terms of the AI design, like only a third of the bots specifies concrete AI behavior or output logic, especially like when students ask for solution or some other behaviors that's not intended. What should AI behave? And lastly, when it comes to the testing of the bots teachers built, we found a strikingly low rounds of turn taking from teachers. Like those teachers usually just spend like 2.3 turn takings with the chatbot when they are testing it. So which I don't think it can like 2.3 turn takings can be very representative when it's comes to the real student AI interaction is definitely insufficient. Yeah, so while this data is like, especially from stage 2 to 4, is not like very great, but it's also super understandable. So from those data, we identified the more specific challenges. So this means like in each stage, like in stage 1, providing context, we think teachers are fine. We can optionally give them more support. And in stage 2, mentioning learning design, it's understandable, like teachers are practicing those learning designing principles, but that doesn't mean they can articulate those learning design. So in our system, one of the design goal is just to provide it in a way that teachers don't need to write it down by themselves. And then same for the AI design, because teachers are not trained to be AI designers. Although I do believe teachers will get better after they interact with AI more. But I think it's also one of the design goal of our system to make AI design more explicit and make the capabilities easier to understand or anticipate for teachers. And lastly, when it comes to testing, I think it's if we don't reinforce this kind of interaction, it might be hard for teachers to like think of it naturally. So as you see in the demo video, we did simulation of the test cases, and we kind of forced teachers to review it and label it as passed before they can even publish the bot. And yeah, here are some more detailed key features that we designed targeting those design goals. And here I also want to highlight the learning context or the using context of the tool. Although in our case, we don't have a lot of data for that. The only context data I know is about those learners are mainly instructors in higher education. So here I just use the demographic data in another of my paper to demonstrate maybe we can analyze the country teachers are from, degree program they are teaching, and along with other demographic information to really contextualize your design. So if this data is for the current project, if I know like maybe my teachers are not just coming from countries speaking English, but also like from Germany or from China, from other countries that the primary language is not just English, maybe I would just provide another version, maybe Chinese version, and then also do a bunch of corresponding testing on that language. So that's one thing maybe we can learn from the context, but it also related to your priority of features. Maybe language is not the priority regardless of the context, but at least we should be aware of the context on some certain level. And then, yeah, so for after we learn about the challenge and the context, then we can do the design, develop, and instrument, and also testing. So here's some main implementation and like technical decisions we made in our system is about the AI infrastructure. So we tried a bunch of different AI infrastructures, including how to let a multi-agent system collaborate with each other, and then do so that it can perform better. So for example, once we allow teachers to edit the conversation and we need to revert it back to the system prompt, we need to make the decision whether it can be done by one agent or multi-agent, and when it's multi-agent, what kind of task each agent do, etc. So we tried a lot of different combinations of this AI infrastructure. We are also in the process of testing the prompt's effectiveness with some learning science experts. So this is from one of our previous work that we already tested some of those pedagogical system prompts. So yeah, Erin, thanks for sharing the CLE framework. So because if we really want to embed some of the learning design or the AI design in our system, we really need to know whether it's robust, not just on one model, but on multiple models, because some schools might use OpenAI, some others are use Gemini, or some of the Anthropic models, DeepSeek models. So we will use those models to produce some output and ask learning science experts to do evaluation with us. Yeah, and after all these implementation and testing, we finally just implemented those design goals in our system. So we allow teachers to upload attachments and write down more of the context. So they are able to provide context in a more convenient way. So, for example, they can upload their syllabus. And then for the learning design, we already provide the templates. So, and also this is a choice that's automatically made by our system, but teachers are also able to change it. And then for the AI design part, we provide agent templates so they can choose from these agents. For example, we have chemistry lab agent. We also have some music lab agent to provide some multi-model experience for teachers. So teachers don't need to implement it or just or searching on the internet and switching between tools. And then lastly is the testing feature, which is I personally think this is the most important since teachers rarely do that before. So once teachers configured the chatbot, we will simulate two conversations. One is the let's say the ordinary path or expected path, and the other one is edge case, which is a relatively problematic student where some students really struggle. So the intention is to really help teachers to think about the guardrails or whether there's a better way to deliver what was the intent of this chatbot. Teachers are also able to add test cases. And once they reviewed all the conversations, they can either, if they feel this is not right, they can edit the bot response or edit student response and rerun this until they think this is acceptable and ready to publish. So all of these efforts are within our research and development team. And the next step would be introduce this tool to the wild. So we really want the real users to have some experience and just talk to us face to face. So for the next step, we are scheduling user study with instructors. So in those one-on-one sessions, we can not only observe what they do, but also ask like a bunch of why questions, or even invite them to fix some of the problems together. So especially when we are enabled by lots of vibe coding tools. So in the user studies, we can even just ask, oh, why you don't like this feature? And maybe the user will say, maybe the system prompt part is too long. Can I just make it folded as default? And I just don't want to see that many text. And then we can just wipe code that, and boom, we can see whether the folded version is better in just a few seconds. And after the user study, we will we anticipate to fix a bunch of problems and then deploy it on the AI for Educator course on Open Learning Initiative so that we can get more of the feedback in a more like scalable way. Yeah, so that's pretty much the case study demonstrating how learning engineering actually work in one of the projects. And I'd like to take questions. Okay, and also let me just take a quick look at the, in the chat.
Yeah, I think Jason Babcock had a question there.
Okay, go ahead.
Jason asked, was there follow-up with those teachers as to why they did not implement or why turn taking was not used more, I guess is the question there.
I think that's a great way to collect data and have a more direct answer to those previous challenges. Previously, I didn't get the feedback form, like especially the form with the emails. So I don't have these like contact information, and I don't think I'm allowed to have this contact information. But I think this, if that's possible, I would like to ask like our collaborators in Open Learning Initiative to see whether we can send just the follow-up forms and collect this kind of feedback or even schedule interviews with them. I personally think interviews are really helpful to get some in-depth conversation, in-depth insight. So it haven't been done yet, but I think that's something I would like to do in the next step. Yeah, thanks for the question.
Heather, you have a question? I think you can voice it if you want.
Hi, this is fascinating. Thank you for sharing.
Thank you.
I'm curious, how long was the course? Is it done in one sitting? Is it a couple hours or is it spaced out? How long were they in the seat or how long did they interact with it?
I might have some brief data, but Erin, do you want to go ahead and share more?
Yeah, the course is kind of self-paced, and although we've been running it with some small cohorts to just generate some data and to talk to them more, um, it's I don't have the data on how long it takes to get through the course. I know it's not built as like a full semester course. It's self-paced, so you can work through it. I think the cohorts have been going through it within a semester, but I'll have to get more data on what is the seat time. Not quite sure on that. Sorry.
That's okay. And the quick follow-up is it completely individual and asynchronous, or do they have any facilitation or interaction with anybody?
The course is self-paced and not an asynchronous. Like I said, we have been running some cohorts like for the SUNY system and expect to probably run some additional cohorts. And we have a community of practice. So I should probably get that information and share it out. So the community of practice is something where anyone who's taken the course is invited to come and share what they've created and talk with other teachers on that subject. So I'll get some of this information that you're asking and post it somewhere where and point you to it. So thank you for those
Thank you.
questions.
It's fascinating. I can just imagine if they are talking to each other, if the learners or if they have questions while they come into it, do they bounce ideas around like that? Or I'm
When
not
we have
familiar
a
with how the
cohort
cohort
session,
works.
yeah, the cohort works that way. So they
Oh,
have a
great.
synchronous meeting where they can ask questions, they can talk about their experiences, they can share their bots that they've created, that sort of thing.
Yeah, plus I also I saw a bunch of like discussion posts in
Mhm.
the course, so I saw a few of their discussions. I also noticed in the Playlab community, I think there are learners copying others' spot and take a try by themselves. And also I saw there were discussions going on under some certain bots. So I think that's very interesting. Yeah, all happened like during this, I think it's during the course time. Yeah, that semester. I know it's not a semester-based course, but it happened during certain time, Yeah.
And thank you, Ruiwei, for mentioning the discussion. We do have discussion activities and exercises to encourage the users, the learners that are in the course at any given time to kind of talk with each other and share things within the course. We're still in the process of analyzing that data, but we'll I'm sure be doing that as well. Tom, you have a question?
Yes. So first, Ruiwei, great job. Thank you so much for sharing. My question might be a little in the weeds, so feel free to kick me out on this one. But I've played with Playlab and with other professionals, done the remix portions on Playlab. There's a lot of fascinating things on it. One of my questions kind of goes to one of the references that Baptiste made earlier, like with XAPI and kind of gathering some of that data. And so there's like an abstraction almost where you're looking at maybe actual physical movements or like little nuanced things that each learner is doing. Have you guys found a way to kind of extract that from the Playlab interactions? Because that's one of the challenges, even with K-12 groups, it's helping to aggregate that information and say, all right, where are the trend lines from overall in the class versus what are this specific interactions for that student in maybe using, for instance, your chemistry bot or something along those lines?
Yeah, so do you mean like is there any way to extract those patterns?
Yeah, so when they're responding all through chat, well, we can't grab the entire chat, but can we do something akin to like a sentiment analysis or determine if there was a understanding and like how do we extract that bit of information from the chat in order to feed that to XAPI or to an LRS? I know that's probably more complicated than a lot of schools are doing, but at the moment, it seems like it's a trajectory that we might be going on. And I was just looking to see if your work at the Carnegie Mellon is kind of leading in that direction, and maybe there's some branches to start to follow.
Okay, I think this is a great question. And now I get it is more like talking about those technical barriers when it comes to the data extraction, data analysis. I think in our case, in the Playlab data extraction case, since we don't have like admin like authentication or like higher like permission of the account. Unfortunately, we are using very like Python-based way to extract all these data from the GUI, the GUI based interface. Yeah, other tools, yeah, we tried a bit, but I don't think it's very, very generalizable in this kind of web-based data extraction. So this might not be like the most exciting like experience sharing when it comes to the data extraction part. I think something might be helpful is probably you can ask like ChatGPT or like Cloud to see whether there's any tools or like you can even ask it to write some scripts to extract the data. So I think that's for the data extraction part. If you, to your knowledge, the existing data extraction tool just none of them works, then maybe you can ask AI to wipe code some scripts to help you on this kind of task. And when you got these data extracted, if you want to know whether there's any common patterns, in our case, since we just have a little bit more than 100 chatbots. Usually in the research practice, we'll hire RAs to do the labeling. But of course, we'll take a look at all the chat histories for ourselves to get a better sense of what is going on. Because usually RAs, research assistants, are not that experienced and they don't understand that much about the research agenda or the research questions. So usually researchers will take a look at the data by themselves and then to decide whether we want a thematic analysis or whether we want to do like a finite diagram, or you can use some more NLP-based approaches. I don't think it's very like I don't think those NLP-based or Gen AI-based approaches are like highly praised in academia, but my personal experience is they are helpful. I don't think it's like there's that much of difference when you are feeding an AI with your data versus when you are labeling it by itself. There are differences, but it's not too much of it when your data is already collected, especially when you are asking for counting the frequency or extracting some common patterns. I think AI is very good at it. And for some other analysis, I'm not that sure, especially when you want to integrate the data into some existing framework. I think it still needs some human labeling to do some double check. Yeah, but I think AI is my good friend. I use it a lot. When the IRB process were the client permit, I mean.
Understood. Yes, IRB does prevent you from doing certain things, doesn't it?
Oh, not that much. If you mention that like the data, anonymized data will be processed through AI, it's also more like of case by case. At CMU, I think I have approved IRB for using AI for data analysis, but I heard it can be very strict by project or by institutions. Yeah.
Great. Thank you, Ruiwei.
Thank you. Yeah, John.
Sorry, I was muted. The data collection that you're talking about, was your focus for this project more about collecting data on the instructors and the teachers and how they interacted and built their chat bots? Or was it intended to collect data on the usage of those chatbots from actual students later on? Or both?
This is a great question. So for the iteration we just get done, I was not in the data collection process, so I just analyzed what I had. In this case is the bot's metadata, like what was the prompt, what was the chat logs, and what was the teacher's feedback. So those are the data I have. But in the future, if there is any teachers willing to or already deployed those bots in their classroom, and if the data is allowed to be shared, I'd be happy to analyze this kind of data, especially like I can show you the screen. Yeah, especially like when we have some simulated conversation. If we have the real conversation, then we can have some like some data that we can validate our simulations. So that would be amazing. That would be great. But more of the case is like not just in this project, it's in most of the project. We can just use the data we have to do the best of estimation or iteration. Yeah. Okay. But if we have the rights to collect more data that's more on target, that would be better. Yeah.
Yeah, I want to add that Ruiwei is actually working with one of my learning engineers, Yue, who developed the course and is really in this constant cycle of looking at data and trying to figure out what data to collect next so that we can continue the analysis. The funder definitely wants us to prove out and give more information about, okay, is there a transfer of learning? Are these instructors then going into their classroom and using these bots? So there's definitely um, follow on work and data analysis to continue doing, and which is one of the reasons why we're also holding cohorts and a community of practice so that we can continue collecting that data because we really do want to know that next step. Does this affect the practice of instruction for these teachers? And it's a process, so we're going to keep iterating and figuring out what we need to know next and collect that data. Very, very iterative, and I have to actually commend both Yue, the learning engineer, and Ruwei on being so nimble in collecting that data. I think that's the key in learning engineering to really, stay in that thought process of what can we collect next. Yeah.
Yeah, I think what Erin said is perfectly aligned with this graph. Like many, many more of the iterations will be going on. Yeah,
Thanks, Ruiwei.
no problem.
We may have time for like one quick question, but I think we'll move forward after if anyone has any burning question. Otherwise, we'll conclude and share more information. Michael?
So, what Ruiwei shared is absolutely wonderful. What do we learn from that about what to look for in other tools so I run across something that looks really intriguing. What might I look for to know that it's going to really support my use of learning engineering processes?
Oh, you mean the project? Like what would be the takeaway from this project, from this case study?
Well, just taking that as an example, and I'm asking it of Erin and Baptiste as
Yeah.
well.
Yeah, I was going to kind of say this in a little bit, which is this is really a demonstration and an example of what we do in the tool SIG. It's not that we have clear recommendations for, what you look for in tools. It's really encouraging folks to use the learning engineering process in their evaluation of the tools they need. What we do in the tool SIG is not necessarily make recommendations, but really collect from the community tools they're using, really nerd out on talking about them and sharing them with the community and inviting folks to come and demonstrate their process and the tools that they have. And then we talk about how that does support learning engineering. And we create this collection because we realize that, you can use a number of tools across all parts of the process. And so what our job is really to share and discuss and talk about their relevance and their usefulness, and quality and value in helping with the learning engineering process. So I think if you come and join our tool SIG and nerd out with us, like I said before, you'll start to learn more and more how to apply this process in your selection of tools that you use. And Baptiste, I don't know if you have anything to add to that. Sorry, I kind of
Yeah, no, not really. I think I agree. I think this case study really shows the process and how we can take the data. To me, is really important to being able to capture the right data and then do some like user testing. And this showed that by iterating on these different parts of the process, then you can get to a better understanding of everything, the design, the data, the user. So it's a kind of holistic view of all these pieces of the process that I think is super interesting here.
Yeah, and
Yeah,
yeah, I
go
think
ahead.
that's great. So to me, some takeaways could be like when it really comes to some steps in the learning engineering, what is a very actionable next step we can take? So for example, quantitative analysis, qualitative analysis, and corresponding methods under that. And also, we don't need to, like, neither in this project or some other of the learning engineering projects, we don't need to wait to be perfect to test with the actual users, because it's probably never going to be perfect, but we can just do more of the iterations and to keep collecting the data and keep improving it until, I think to me, it's acceptable for most of our stakeholders. I don't think it's gonna be perfect any day or in any cases, but I think it's improving, and I think that's really important. Yeah. Yeah, just don't hesitate to get feedback and to try it in the real scenarios.
Yeah, good
Awesome.
advice. Thank you.
Thank you.
So, I think we
Yeah.
have another poll. We, um, there we go. So, if you're interested in joining us in the Tool SIG or any of the other ICICLE MIGs and SIGs, which are really where the real work of ICICLE happens, is really getting together with all of these folks and talking through your use cases and really talking through how you can incorporate the learning engineering process more into your work. So if you're interested, please complete the poll. And Baptiste, you wanted to share our repository?
Yeah, thanks for sharing the poll, and also wanted to share before we end that this is a survey where you can actually add your tool to our repository of tools, and we're always considering any different tools and have these conversations around them. So we might use this information that you send to schedule demo and do some discussions. Also, we may reach out about the tool and learn more about it. So,
Thank you. Can we go to the next couple slides just to wrap up here? So yes, here are the special interest groups and the market interest groups, and they intersect, as you can see. There's folks who really attend both types of meetings. The special interest groups revolve around particular topics in learning engineering, and the market interest groups are really like how is that applied in the different sectors and domains that intersect with learning engineering. Yeah, so find your peeps and join the meetings. Next slide. I can't remember if there's, and you can reach out to any one person. These are the chairs and co-chairs of these different MIGs and SIGs. So we're always looking for new folks to come and share their experiences. And so reach out to any of us. And I don't know if there's any more slides. I think that'd be it. Oh, yes, and other resources. So ISO collects a number of resources, and we try to share these out with our community. We have developed different types of tools and ways to start tracking your learning engineering process and capturing more of your design decisions, like with the lead tracker, the decision tracker. We get together and really try to um, produce assets and resources around learning engineering. So feel free to go and peruse those and use those at will. Thank you guys so much for coming. This has been a really great group. I hope you found it interesting and helpful, and hopefully it gets you even more interested in learning engineering to come and join us at ICICLE and join us in our SIGs and MIGs. Really looking forward to seeing more of you.
Thank you, everyone.
Thank you, everyone.
Thank you.